Welcome everyone. Today we are going to discuss a topic, particle swarm optimization, or that is called the PSO algorithm for the big data optimization. And you can see the diagram where what is the swarm optimization. Swarm means a group of entities or group of objects, and from this you can find how they are moving from different location place to another place, and how they are optimizing their path to collect the food or moving from one place to another place. So that is the example of the fish schooling ant colony, and this is the example of the ant colony optimization, how the ants are collecting food if there is any interrupts are also available. Based on their pheromone, one of the chemical that generates when they move, it generates for the few seconds, and the second ant follows this chemical and continue until they got the food. So, in the aim of this session is to familiarize the students with particle swarm algorithm and its applications, and objectives are the demonstrating the PSO, describe the applications, and list of the properties, and solving one problem. The outcomes are to define the problem, PSO algorithm, describe the properties and application of particle swarm algorithm, and summarize the concepts with their applications. Now, before going to PSO algorithm, now what is the history of the history of the PSO algorithm? It is generally first developed by the Kennedy, one socio-psychologist, and Albert Hart, an electrical engineer, when they studied the different ants and different particles in the swarm, and they found some interesting result that they can implement this for the optimization. So, in the PSO there are number of simple entities called the particles are placed in the search space for some problem or function, and each evaluate the objective function and its current location. So, PSO algorithm is based on the current location and current velocity where the particular particle is moving, in which direction it is moving, and from the current position you can find the local optimum, and from all the local optimum you have to find the best fitness, that is the best location with those where the members are present. And the random number, that is the probability what are using here you are using some random number, because you don't know how the swarms are moving. So, we predict some movements based on some probabilistic calculations. Again, it should satisfy a fitness function, that it may be any objective or any constant problem or maybe optimization problem, and that may be any real life application, that is real life concepts. Now, in the PSO, one important point is the cooperation. So, in the cooperation means every particle will cooperate to each other to achieve a particular goal. Now, consider a fisherman example. A fish is hidden, and there are so many fishermen are available. So, a big fish is available in the deep sea. So, there are so many boats are available, fishermen are available. They will find what is the depth of the sea, whether the fish signal is available or not. If not available, they communicate to the nearest one. In this way, in the final, they will got that one fisherman got the fish. So, that it is a cooperation, that is everyone is cooperating to get a particular goal. Another one is the collaboration. In the collaboration, individual will work in a single goal, but in the cooperation everyone collaborate to get the goal. But in the collaboration, the goal is shared among all the pupils. Now, in case of cooperation, what are the requirements? One is the position, a velocity. Next one is the ability to exchange information with its neighbors, ability to memorize a previous position, ability to use information to make a decision. The basic idea. Each particle is searching for the optimum. Each particle is moving and hence a velocity. Has a velocity. Each particle remembers the position it was in where it had its best result so far. That is called the personal best or P best. But this would not be much good on its own. Particles need help in figuring out where to search, because there should be cooperation among the particles. The particles in the swarm cooperate, they exchange information about what they have discovered in the places they have visited. The cooperation is very simple. In basic PSO it is like this. A particle has a neighborhood associated with it. A particle knows the fitness of those in its neighborhood and uses the position of the one with best fitness. The position is simply used to adjust the particle's velocity. So already we discussed this one. So in the left side you get the one picture, that is a standard particle swarm optimization PSO. So G best is our target or the goal, and for every case, every particle it has the P best, and from the P best again we find what is the velocity of the two particles and getting the best one nearest to the another particle. Now what is the basic initialization, position and velocity? That you have to initialize the position and velocity for the PSO. So you can see the initial values are green and blue is the boundary values, and where the particles again they will move in different directions. So you cannot say that they will move in the single direction, because our solution is to optimize a function or optimize some activities. Then next one is the what a particle does. Now in each time step, that is every time a particle has to move to a new position, it does this by adjusting its velocity, and the adjustment is essentially like your current velocity plus the weighted random portion in the direction of its personal best, that is you calculate the P best, plus a weighted random portion in the direction of the neighborhood best. So you have to check the neighborhood, you have to check the direction to the P best, again you check the velocity. So every time you will update the velocity with the old velocity plus new velocity. Now what are the steps? First step, you put some particle on it. You can do it at random or an irregular way or both. Then how many particles you can take? So generally it may be take 200 or any size depending your practical application, how many particles required for your objective function. Again there is a mathematical derivation is available, and we are keeping the mathematical derivation for this because we are going to only the simply way to explain the PSO algorithm. Second step is you define a velocity for each particle, usually at random. So you assign a random number. You can set all initial velocity to 0, but experimentally it is usually not the best way. So generally you don't take any initial velocity as 0, because some particles are moving sometimes. We will expect that in the past some particles are already they have the velocity. So what are the neighborhoods? So you can see that there are two types of neighborhoods. One is the nearest particles, that is called the geographical. So in the geographical there may be common elements or common particles. Next one is the social, how they are related to each other and how they can find the optimal solution, optimal path from between the two particles or multiple particles. And what is the global? After getting the social and the geographical, you get a global optimization. So this is this is global, that all are collected in a single page. Another one is the circular one. In the circular one, you have that is the particles are in circle, they are related to each other, and the nearest neighborhood is your circular neighborhood, that is your left side and right side. So every particle has the left and right. So based on the circular neighborhood, every particle is related to each other. Then what is the psychological compromise? The psychological compromise is that, suppose you are a particle, assume. By the way, Jim Kennedy has designed a nice game in which you compete with such stupid particles. That is, you compete with one particle. I have it there, and if we have time, you will see it is almost impossible to beat it. So I already played so many games also. You have to kick, you have to select some particle or some object, and it is moving randomly. So it is difficult to catch the object. You can compute how good it is your position. Again, you would check your position, whether you are going in the wrong position or in the correct position. That is required for to compute the objective function. You remember the best position you ever found. So what is the best position already you got in the previous iteration or previous solution, that you have to remember. And you can ask your neighborhood for this information. They also have the memorize and choose the best one. So your neighborhood also remember your position, and they will help to get the desired goal. So there are three types of tendencies. One is the audacious, following your own way, just using your own velocity. Conservative, going back more or less towards your best previous position. Sheep-like, going more or less towards your best neighborhood. So there are three types of tendencies are there in your psycho-social compromise. And generally in the PSO, all are combined. So every particle moves towards each other. They select their own way. They either go to the back or go to the front or forward. So three tendencies are combined in the PSO to get the global optimization value. So you can see this here in the diagram, the psychosocial compromise, individual particles. Now here I am, my position is X, and I want to go to the global. The two options are there, my best performance, the best performance of my neighborhood. So this is my best performance. I reached here in the PI, position I. That is your P best. But I need to go to my friends or my neighborhoods. That is the G best. That is the global best. So I am going to the neighborhoods. So you are either X, you are moving to the P best to another location independently, or you want to go to your friends. And the velocity you have to identify, and this velocity will be randomly select whether you are going to my best performance or you are going for the best performance of my neighborhoods. That is your combined effort. Now go to the PSO algorithm. The PSO algorithm has different concepts are there. We are moving in the groups. You are either going in the 3 dimension or 2 dimension. So consider this one. A particle swarm is composed of 3 dimensional vector, where D is the dimensionality for the each space. Because your dimension means you have velocity and position. So there are two dimensions now. Third dimension is to optimize a value. That is the location in 3 dimensions. You don't know whether you are to moving. These are the current position xi, the previous best position pi, and the velocity vi. So it is called the 3-dimension vector: current position, best position, and the velocity. The current position xi can be considered as a set of coordinates describing a point in the space. On each iteration on the algorithm, the current position is evaluated as a problem solution. If that position is better than any that has been found so far, then the coordinates are stored in the second vector pi. The value of the best function result so far is stored in the variable that can be called p best I. That is the for ith particle. That is the previous best. Now for compromise on later iterations, the objective of course is to keep finding better positions and updating pi and p best I. New points are chosen by adding vi coordinates to xi, and the algorithm operates by adjusting vi, which can effectively be seen as step size. So based on the step size, you have to adjust the velocity. The particle swarm is more than just a collection of particles. Now go to the concept on the topology. So in the topologically, typically consider bidirectional edges connecting pair of particles. So j is in i's neighborhood, I is also j's neighborhood. So you have to identify who are the neighborhood to each other. And the vector pi for that best neighborhood, which will be denoted as pg. Now which is the best neighborhood, that is the who will giving the best optimization value. The potential kinds of population called the social networks are hugely varied, but in practical or in practice, certain types have been used more frequently. In the particle swarm optimization process, the velocity of each particle is iteratively adjusted so that the particle stochastically oscillates around pi and pg locations. So the particle will be in the your personal current location and the next to your group or neighborhood position. So mathematical model, each particle in particle swarm optimization of PSO has an associated position, velocity, fitness value. Each particle keeps track of the particle best fitness value and particle best fitness position. A record of global best fitness position and global best fitness value is maintained. So using all the basic parameters to implement the PSO algorithm. Now what is the data structure? In the swarm of population, already you know this one, there are so many swarms are there, particles are there, first particle, second particle of ith and last particle. Best position and fitness in swarm. Now go to the individual level. So go to the ith position. So when you are going to the ith position, you see that when you are going to the ith position, you see that the swarm ith position swarm also position, velocity, fitness, and from this a particular position I, again you calculate the best position and best fitness. And this is the PSO algorithm, and the flowchart gives the details of the what are the steps you do follow, how many iterations you count, and how you can process the PSO algorithm. The algorithm, the pseudocode of the PSO algorithm is for each particle, initialize particle, do for each particle calculate the fitness value. If the fitness value is better than its personal best, set current value as the new p best. End. So this loop will continue to get the p best. Next, choose the particle with the best fitness value of all as g best. So initially like that all the best values are g best. For each particle, calculate the particle velocity according to equation A, update the particle position according to equation B, and it will continue. So you see the in the right side, the equation A is only for the calculating the velocity. So velocity of I plus 1th position, that is the iteration, is equal to V of I plus C1 into randomized number or probabilistic number into P best I minus present I plus C2 randomized probability number into G best I minus present I. Equation B is the position of the particle, present I plus 1 is equal to present I plus the velocity of I. So previous I will be calculated, that is the V will be calculated to get the current position of the particle. While maximize or maximum iteration or minimum error criteria is not attained. So we will continue this process until the maximum iteration already given 100, 200 or 500. Again minimum error criteria, that is the error between the threshold error between the current solution and previous solution. If this is less than this one, then you can stop the process. So this is the detailed algorithm of the PSO. So every line is calculated and you are getting the best positions, best fitness values. Again you are getting the swarm positions for the individual one, whether maximum minimum position, again based on the boundary values, and you calculate the optimized or final particles. Then what are the parameters of the PSO algorithm? The parameters problems are number of dimensions D, lower bound minimum x, upper bound maximum max x. And hyperparameters of algorithm, the number of particles, how many particles you are selecting, maximum number of iterations, inertia W, that is the stable state, condition of the particle C1, that is the, again it is a constant, depends on the users, social influence of the swarm C2. So these two values are C1, C2 are generally you are giving randomly or based on the previous experience if any other algorithms are implemented, and these are two. And random number, you can put any random number to identify the direction or to generate the direction to the particles. What are the advantages? Advantages are the one is the insensitive to scaling of design variable, that not sensitive to the scaling, you can take any type of variables, any type of data. Derivative free, very few algorithm parameters, only are P based, G based, velocity and position. Then very efficient global search algorithm, easily parallelized for concurrent processing, that you can parallelly implement the PSO. It is easy to implementation, so it can be applied both in scientific research and engineering problems. Again it is the very simplest one also. It has a limited number of parameters and the impact of parameters to the solutions is small compared to other optimization techniques. The calculation in PSO algorithm is very simple. Some techniques ensure convergence and the optimum value of the problem calculates easily within a short time. PSO is less dependent of a set of initial points than other optimization techniques. It is conceptually very simple. Disadvantage is slow convergence. Again you take the so many time to get the convergence. Weak local search ability. PSO algorithm suffers from the partial optimization, which degrade the regulation of its speed and direction. So generally it is not giving the exact optimization value, it gives the partial optimization. There are the applications, signature verification, engineering, electrical, motors, finance, economics, detection of the faults, metallurgy, security, military, fuzzy neural network. Again metallurgy you can apply. Then you can go for the vehicle routing problems, signature verification. So there are so many applications are available nowadays, also many applications are developing now. Now example, one of the example for the network. find the maximum of the function x square minus 5x minus 10, range is minus 10 to 10, and we are going for 9 particles. You have taken the initial position, and initial position is given, and all initial positions are now calculated based on the previous one. You take the 0, then calculate the optimization function, then take the constant value c1, c2 is 1, and number next iteration is 0 plus 1. Now p best, calculate the p best based on the formulas, then find the g best, the minimum of the all the p bests, that is the 3. Then go to the velocity, select randomly any two values r1 and r2 and get the in the range 0 to 1 and find the velocity of the all the particles, then calculate the new values of the x1, that is x1 to x9, then stop the getting. It is only for one step. We are not verifying any error here. We are only calculating one step calculation. So there are some questions. Define PSO algorithm, explain the PSO algorithm flowchart, list out the advantage, disadvantage of PSO algorithm, list out the application of the PSO algorithm. I hope all of you understood what is the PSO algorithm and how it is applied and what are the parameters are available. Okay, thank you.